One of the most interesting questions in parapsychology is the question of coincidence. Are statistically significant results always an indication of psychic phenomena? This question is probably one of the most intriguing because it makes you think whether the result that has been observed was really due to psychic abilities or was it just coincidence or dumb luck. Truth is, statistically significant results aren't always an indication of psi abilities, and I will explain why that is the case. In statistics, when it comes to hypothesis testing, there is always this percent error risk of rejecting the null hypothesis when it is in fact true. This error is known as a type 1 error. A type 1 error in statistics is when you reject a null hypothesis when it is in fact true. Causes of this can be due to lack of controls or things that aren't experienced to control. However, one of the most common case or explanation is coincidence. Coincidences happen all the time, and they are inevitable as more trials are included or as more studies are included. In the laws of probability, things that seem unlikely are actually much more likely in the long run. This is because as more trials are included, the more likely the unlikely becomes. Now, since this is the case, we should expect anomalous studies showing statistical significance that are in fact due to chance and not anything else. This process is known as the law of large numbers, and it explains how type 1 error, or rejecting the null hypothesis when it is in fact true, happens. So to answer the question in the beginning, the answer will be no. Statistically significant results aren't always an indication of psi abilities. However, there is a way to determine whether the studies are in fact due to coincidence or was it really due to psi abilities. In order to determine the likelihood of coincidence, you must first determine the probability of type 1 error. The probability of the type 1 error is actually not that hard. The probability of the type 1 error is actually based on the alpha level or the significance level of the test. Now, in order to clear that misconception, as I said before in my previous videos, the p-value is not the probability of a type 1 error occurring. However, the type 1 error probability is, however, in fact based on the alpha level of the test, which is basically the significance level. As I explained before, the significance level can be 0.05 or 0.01, and it is also used as a borderline to determine whether or not the null hypothesis should be rejected. So if my alpha level of the test is 0.05, then my type 1 error probability will be 0.05. Now you may be asking, if the p-value is less than 0.05, does that mean that the probability of type 1 error is less? The answer is no. As I mentioned before, the p-value is not the probability of a type 1 error occurring. The probability of the type 1 error occurring, once again, is based on the significance level or the alpha level of the test. Alpha significance are the same thing. Now, what does a 0.05 type 1 error probability mean? A 0.05 probability level actually means that there is a 5% chance of rejecting the null hypothesis when it is in fact true. It can also be stated that 95% of the population that take the test will in fact fail, while the 5% will reject the null hypothesis when it is in fact true. Just like the type 1 error probability of 0.01, that means that 99% of the population of people or the studies themselves will fail to reject the null hypothesis, while only 1% will reject the null hypothesis when it is in fact true. Now, in order to determine whether the positive studies are in fact due to psi abilities or coincidences, the first thing you need to do is test it under a two-tailed hypothesis testing. So what you would do is, for example, if I have 3 positive studies out of 20 studies and my alpha level was 0.05, that means that 95% of the studies will be due to chance, while the 5% will falsely reject the null hypothesis. But the question here is, are those 3 positive studies out of 20 studies in fact evidence of psi-phenomena or coincidence, even though the 3 out of 20 studies is more than 5%? To answer this question, you'll have first to create a null hypothesis and an alternative hypothesis. In this case, our null hypothesis will be that the studies are in fact due to coincidence and not based on psi-phenomena, while our alternative will be that yes, the 3 positive studies are in fact due to psi-phenomena. In order to test these hypotheses, we must first calculate the p-value and z-value according to the 0.05 probability. So in this case, our null hypothesis will be exactly 0.05 or equal 0.05, since the null hypothesis in the population never claims a change or an effect, while our alternative hypothesis will be not 0.05, in other words, not equal to 0.05. Now let's put it to practical use. Example 1. In the ESP meta-analysis, there are a total of 20 independent studies. 3 of them are found to be statistically significant at the 0.05 significance level in favor of psi-phenomena. Are the 3 significant studies evidence of psi, or are they nothing but coincidences? Step 1. Determine type 1 error probability. Remember, type 1 error probability is the same as the significance level or alpha level of the test. Step 2. Create a null hypothesis and an alternative hypothesis. The null hypothesis in this case will be 0.05 and the alternative hypothesis will be not 0.05, which eventually leads us to a two-tailed statistical test. Step 3. Calculate z-value and convert to p-value, and which is the formula is z equals parentheses k, which is the number of successful events, subtracted by m, which is the mean of the binomial sampling distribution, positive or negative 0.5, divided by the standard deviation of the binomial sampling distribution. Step 3. Calculation. There are 3 out of 20 significant studies, and we want to know if they are not due to coincidence or they are due to coincidence. In order to find this out, we must first calculate the mean of the binomial sampling distribution and the standard deviation of the binomial sampling distribution. If you look at my previous video, it was called Parapsychology Statistics 101, z-value, approximate p-value converter in z table or something like that. You will learn how to do these formulas. Now, skipping all the steps, the mean binomial sampling distribution is 1, which is m, and the standard deviation of the binomial sampling distribution is 0.9747, which is q. Now, putting that all together, we get a z-value of 1.53. Now, using a z-score table, we have a z-value of 1.53 and a p-value, a two-tailed actually, of 0.15. Now, looking at judging at the p-value, we can easily say that no, the 3 positive studies are due to coincidence and not evidence of psychic phenomena. Example number 2. In the parapsychology database of 100 solo studies, there are a total of 17 studies that are statistically significant at the alpha 0.05 level of the test. Are the 17 studies evidence of psychic phenomena or coincidences? 17 out of 100 studies significant. Now, there are 17 successful events. The mean binomial sampling distribution is 5, and the standard deviation of the binomial sampling distribution is 2.1794. Now, judging by the z-value, we get a z-value of 5.27. Now, using a z-table converter, we have a z-value of 5.27 and a two-tailed p-value of 0.00001, which is 1 in 10,000. Excuse me, 1 in 100,000. Yes. So we can, judging by the p-value, we can strongly conclude that yes, the 70 studies are strong evidence of psi and not coincidences. Example number 3. In the parapsychology database of 20 studies, there are 3 studies that are statistically significant at the 0.01 alpha level of the test. Are the 3 studies evidence of psychic phenomena or coincidences? In this case, our null hypothesis will be 0.01 and our alternative hypothesis will be not 0.01 or 1% chance. Now, going by 3-step calculation, there are 3 successful events, and the mean of the binomial sample distribution is 0.2, while the standard deviation of the binomial sample distribution is 0.445. Now, looking at the z-value, we get a z-value of 5.16. Now, using a z-table converter, we actually get a z-value of 5.16 and a two-tailed p-value of 0.002. Now, judging by the p-value, we can conclude that yes, the 3 studies are strong evidence of psi and not due to coincidences. Yeah, and that's exactly how you determine a coincidence when in a study in hypothesis testing in statistics. Alright guys, well, that's the end of the lesson, and if you have any questions or concerns, please let me know in the comment section. And if you like my tutorial, please leave a like, and yeah, thanks for watching.